value of general annuities
and future value of general annuities.
So, let's go on to the tutorial.
If you wanna learn some math with us, come and see with Infinity.
So, the first lesson for this video is present value of general annuity. We have this formula which states A sub B is equal to R times 1 minus the quantity of 1 plus R over N to the power of NT, negative NT rather, over R over N. Now, before everything else, we have a second solution. We need to convert this problem when we encounter general annuities. So, the formula of the converted R over N is R over N is equal to the quantity of 1 plus R over M to the power of K minus 1. So, these are our two formulas. Formula number 1, number 2. Let us now determine what the meaning of each variables are. So, R is our effective rate of interest. This small r is our rate. The N is the payment period. The T is our time. The M is our conversion period. Conversion or compounded period. And the K, this is our conversion period divided by the payment period, or M over N. To get the K, we need to divide M over N. So, with this in mind, let's go to our first example.
So for this problem, we have Dave decides to invest 150,000 pesos every 2 months in a bank which offers an interest rate of 6% compounded semi-annually. How much to invest in 3 years? First, we need to locate the given. We have R is equal to 150,000, N is equal to 6 because it is paid every 2 months. R is equal to 0.06 because we move the decimal place twice to the left. M is equal to 2 because it is compounded semi-annually, and a time of 3 years. Our K, which is M over N, is 2 over 6. Like what is in the given, so 2 divided by 6 is equal to 1/3.
Now, let's go on to our solution. We should first convert R over N in the formula to make it into a simple annuity. Now, R over N is equals to quantity of 1 plus R over N to the power of K minus 1. So let's substitute the values from the given to this equation. So 1 plus 0.06 over 2 to the power of K, which is 1/3 minus 1. First, we need to divide 0.06 over 2, which is 0.03. Added to 1, now it is 1.03. 1.03 to the power of 1/3 is 1.009901634 minus 1. Now, we should subtract it to 1, and we have R over N is equals to 0.10099011634. And there you go. Now let's proceed to the main solution, which is A sub B is equal to R times 1 minus quantity of 1 plus R over N to the power of negative NT all over R over N. Now let's substitute the values of the given to this equation. Then we have 150,000 times 1 minus quantity of 1 plus 0.009901634 to the power of negative 6 times 3 all over 0.009901634. Remember the rules of PEMDAS. So let's first solve the numbers in the parentheses. 1 plus 0.009901634 is 1.00901634 to the power of negative 6 times 3, which is now negative 18. So we have 0.83748. So we have now 0.837484257 1 minus 0.837484257 is 0.162515742 divided by that number to 0.009901634. Then we have 16.4130226. Finally, multiply that to RR, which is 150,000. So the present value of general entity of this problem is 2,461,953.389. That concludes to our example number 1.
So, our second and last topic for this video is about future value of general annuity. So, our formula is A sub F equals R times the quantity of 1 plus R over N to the power of NT minus 1 over R over N. So, if you could recall, this is the same formula as the future value of simple annuities, but there is a difference. We need to convert R over N into another formula. So, that formula is R over N is equal to quantity of 1 plus R over N to the power of K minus 1. So, this is, we need to convert the R over N if we encounter general annuities. So, what do these variables mean? So, RR, the capital R, is the effective rate of interest. The small r is our rate. The N is the payment period. The T is our time. The M is the conversion period. And lastly, our K, we can get the K if we divide our conversion period and payment period. So our K goes like this, M over N. So Take note, the R is the pesos sign found in the problem. The rate or the percentage numbers found in the problem. So the time is in years, payment period, then conversion period. So let's go on to our first example.
For the first example of finding the future value of general annuities, we have this problem. A businessman invests 310,000 every year in a bank which offers an interest rate of 6.5% compounded monthly. How much will the total value be after 6 years? As always, let us first find the given by reading the question properly. R is 310,000, N is 1 because it only occurs once a year. The lowercase r is 0.065 because we move the decimal place twice to the left. Don't be confused on this part. Always move the decimal place twice to the left if the interest rate is presented in the percentage form. Our T is 6, M equals 12. Lastly, our K, which is 12 over 1, is still 12. Before anything else, we should convert the R over N from our main formula. This is the first process in solving general annuities. So R over N is equal to the quantity of 1 plus R over M to the power of K minus 1. Substituting the values, this becomes the quantity of 1 plus 0.065 over 12 to the power of 12 minus 1. Let us first solve 0.065 over 12. Which results to 0.0054166667. Add that to 1, it then becomes 1.0054166667. Raise that to the power of our K, which is 12. We have 1.066971856. And lastly, subtract to 1, then our R over N is 0.066971856.
After getting our R over N, let's move on to the main formula, which is A sub F is equal to R times the quantity of 1 plus R over N to the power of N times T minus 1 all over R over N. Before solving, we need to substitute the values. Just look between the given and the solution. So 310,000 times the quantity of 1 plus 0.066971856, which we got from our first solution, to the power of 1 times 6 minus 1 all over 0.066971856. Using the PEMDAS method, we should first solve the values within the parentheses. So if we add both of these, our answer is 1.066971856. That to the power of 6 is 1.475427,197. It is better to write each step so as to avoid confusion when reviewing later. Now, subtract that answer to 1, then we have 0.475427,197. Next, divide that to 0.066971856, and the answer is 7.098910274. Now that we have answered the values in the bracket, the remaining step is to multiply that to our effective rate of interest, which is 310,000, 2,200,662.185. That is our answer for this example.